Hello everybody, this is Joshua, KI5SIJ, with all things ham radio, batteries, and more. Alright, today in this video, what I'm going to cover is NVIS communications, also called NVIS. NVIS communications. We're going to talk about communicating within a local area or a local region using HF ham radio. In this video, we'll discuss what is NVIS, how it works, what to expect when using it, and recommendations, as well as a quick video about a recent antenna build that I did earlier today. Alright, so we're going to proceed on. I got a little, about 10 or 12 slide presentation with a bunch of information I want to share with you. So we'll go through that right quick, and then at the end of the video, I'll show you the little antenna build that I did. Alright, so for those of you that have never seen any of my other videos, I'll introduce myself. My name is Joshua. I've been a licensed ham radio operator since October of 2021. I'm a proud member of the Crossroads Ham Radio Club out of Ganado, Texas. I'm also very involved with stuff like Field Day and different events like that. I love participating in all those types of events. It's a great time to share and learn. Share knowledge and learn more. So I'll always promote joining and participating in those types of events. The purpose of this video is to share knowledge regarding NVIS communications. I will discuss what is NVIS communications. We'll clear up some very common misconceptions regarding NVIS, and we'll even provide some recommendations. We'll also be covering what to expect out of NVIS and how to make easy and cheap antennas easy to deploy, and what frequencies are best for using NVIS communications. I do not profess to be an expert at anything ham radio related. However, I do love sharing what I have learned in my personal experience while participating in the great ham radio hobby. Please feel free to email me with any questions you may have, and I have attached my email here at the bottom of the screen. Alright, so we'll get started off. What is NVIS or NVIS? Well, NVIS is an acronym for Near Vertical Incidence Skywave. NVIS describes a type of signal, generally HF, which allows communications within a close local radius. Very good to be used for like a local area or local region. NVIS coverage can range anywhere from 10 miles to 400 plus miles. The upper end of that range is debatable. There's a bunch of conflicting information on the internet that says it can be anywhere from 300 to 600 miles. I just put 400 miles. That seems to be the most referenced number that I found. There is no difference between NVIS and conventional skywave propagation. This is kind of important to know, but even though I was very interested in NVIS, there was a lot of confusion about what it was, how it worked, and whatnot, and that's what led to the creation of this video. But know that there's nothing different between an NVIS and a conventional skywave propagation. The distinction arises solely just from the different desirable radiation patterns of the antennas. For instance, NVIS, which is near vertical, and horizontal for conventional long-range skywave propagation. So NVIS is going to be more of a vertical propagation of your signal, and the regular skywave propagation is going to be more of a horizontal long range. This particular setup, NVIS, was very commonly used by the military and has been for a very long time. They use it for base-to-base or base-to-remote deployment, very low-power type communications. It makes it easier to deploy communications between endpoints, and using as least amount of power as possible prevents surrounding entities from being able to interfere with some of that communication. Works very good in the mountains or hilly area because the signals are coming in vertically and not horizontally. How does it work? Well, when setting up a station with an antenna specifically configured for NVIS communications, The antenna generally transmits radio waves vertically anywhere between a 60 to a 90-degree angle from the Earth's surface. Now, that particular angle of degree there, I've seen varying pitches. Some people say 70 to 90 degrees, some say 75 to 90. I just put the biggest pattern that I saw. It was 60 to 90 degrees, and that's what we're going to go with in this presentation. You may find conflicting information, but for the most part, 60 to 90 degree angle from the Earth's surface is what we're looking for NVIS. These signals are reflected down to the Earth from the ionosphere in a pattern centered around the transmitting antenna, which provides a coverage which is known as the NVIS radius. This pattern resembles an upside-down half grapefruit and is sometimes also referred to as what we call a cloud warmer. NVIS can generally provide communications between 10 to 400 miles, but it all really depends on the conditions, the frequency, and the time of day that you are communicating. Frequencies used for NVIS communications range between 1.8 megahertz to 8 megahertz. Those are the most common frequencies to be used for NVIS, is 1.8 megahertz to 8 megahertz. Some frequencies between 8 megahertz to 10 megahertz may work closer to the equator line. However, those frequencies are generally very unreliable. The most common bands used for NVIS is 40 meters, 60 meters, and 80 meters. In some areas, 160 meters and 30 meters may work for NVIS communications. It's been my personal experience that 40, 60, and 80 seem to be the most common and the ones that work the most reliably day in and day out. All right, what to expect from NVIS? Well, generally, you never need more than 100 watts to work other NVIS stations within the NVIS radius. In most cases, you can work these stations on low power or even QRP level power. Works best when talking to other stations who are also configured and set up for NVIS communications. Now, I want to talk about this for a minute. So, NVIS does work best when you're talking from an NVIS station to another NVIS station, but I have talked to people before that did not have an antenna set up for NVIS communication, and they were still able to hear me, and I was still able to hear them. Now, sometimes what I have found is their signals may be a little bit weaker than somebody who might have an antenna set up for NVIS communications, but communication can still be made with those folks that are using non-NVIS style setup communication stations. So did want to put that out there. It does work best when you're talking NVIS station to NVIS station. And what makes an NVIS station? Well, let me talk about that right quick. An NVIS station is comprised of just a HF radio and an antenna that is set up and configured in a configuration that supports NVIS properties. And we'll talk more about that further in the presentation. But what makes an NVIS station is the configuration of the antenna and the frequencies that you are using in combination with the configuration of the antenna. All right, so when you're talking from an NVIS station to an NVIS station, chances are both parties can use less power to communicate. If you're talking from an NVIS station to a non-NVIS station, you're going to probably need to use more power to be able to communicate, but it can be done. All right, so we'll move on down. Inverted V dipole antennas seem to have NVIS properties even when set up with feed points at the 30 foot up in the air and the end points of the antenna on the ground. This is one of my personal experiences. One of my antennas that I DX on is a inverted V. It's a full-length inverted V, 10 meter through 80 meter off-center fed dipole. And I had the center feed point. I put 30 feet here. I've had it up at 30 feet before. Right now it's up about 25 foot, and I can work DX on it, but I also have some NVIS properties. What I have found is that my NVIS properties on that inverted V are weak. They do work, but they are weak. What would make it better is if I would lower that antenna feed point down closer to the ground. And we'll talk about that a little bit further in the presentation, but know that some antennas can have both DX and NVIS properties. Now, what will generally happen is one would work better than the other. In my case, my antenna works better for DX than NVIS. But if I was to lower the feed point and spread out the antenna, make it more into an antenna for NVIS communications, it would work DX less better. So keep that in mind. Again, we'll talk, and there's some conflicting information about that topic on the internet too. I'm just providing what has worked for me in my personal experience. I've done a lot of testing with all this stuff, and I've made a bunch of observations, and that's one of them. But we'll talk more about that later in the presentation. When using horizontal dipole antennas 3 to 5 foot above the ground with a reflector below it, expect very low noise floor and very good strong signals from other NVIS stations. I do set up some dipoles about 3 to 5 foot above the ground and about 6 inches above the ground. Directly below the antenna, I set up a wire to use as a reflector. We'll talk more about that in a few slides down. You can generally work other NVIS stations within the NVIS radius on low power. It's great for QRP communications for local nets and for local communications with other radio operators. It also makes a great option for local emergency communications in the time of natural disasters. All right, hardware involved for NVIS station is very portable. What I mean by that is that it doesn't take a lot of equipment or big amplifiers or anything major or very large to do NVIS communications. You can do NVIS communications on a QRP rig and a wire center-fed dipole wire antenna, and it'll work great. It's a very small footprint. You can put it in a backpack. I've actually done this before. It works great. If you're using an inverted V antenna for NVIS, like I mentioned on the previous slide, you may hear and be able to work DX. However, please note that the inverted V antenna set up in an NVIS configuration are focused on local communications primarily. Any DX communications worked on a inverted V NVIS configured antenna, signals may be weaker, and your signal out to them may be weaker because your antenna is configured primarily for NVIS communications. So I would think of that as being a compromised DX antenna. It's configured for NVIS communications, but you are hearing some DX stations. I would think of it as an NVIS configured antenna with compromised DX properties. It's based upon my personal experience. I've found some conflicting information about that on the internet. That's one of those things I would highly recommend for you to just test out yourself. Get you an inverted V antenna and see what happens in your environment. For me, if I keep my antenna feed point up about 25 foot and have it set up as an inverted V, I can work some DX and I can work some NVIS, but neither one of them are great. I either need to go higher to get better DX or I need to go lower to get better NVIS. 80-meter center-fed dipole about 4 feet up off the ground, horizontal, provides one of the best and cheapest listening low noise antennas I have ever personally used. So I'd set up an 80-meter center-fed dipole for NVIS about 4 foot up off the ground in my backyard. It was a little over 120 foot long, and that has proven to be one of the best listening antennas I have ever used on my rig at home. And it's also great for NVIS though. Put a reflector underneath it and the antenna is about 4 foot up off the ground. I'll actually show you a video of me making one of those antennas, which I did earlier today, just so that I can demonstrate the process. I have worked stations as far as 300 miles away on NVIS QRP with just 5 watts and have received a full 5.9 plus signal report before. I've actually talked from the Houston area into New Orleans several times. I've talked into Mississippi a couple of times, but the furthest point I've ever talked was it was about 305 miles I was on 5 watts and I got a 5.9 plus report. So when everything is set up correctly, it can be done with low power and great full signals. There again, that's why this is great for emergency communication situations. This is great for talking to local ham radio operators or even joining in on local rag-chew nets within your local region or state. Now what I want to do is go over some misconceptions about NVIS. Misconception number 1 is that NVIS describes a type of antenna used for local communications. That is not the case. There is no such thing as an NVIS antenna. Now, I have been talking with a bunch of my friends and buddies and local club members, and I have been one to blame for referring to antennas that I use to talk on NVIS. I'd call them an NVIS antenna. And actually, there is no such thing as an NVIS antenna. That antenna that I use for NVIS communications can be used for NVIS or it can be used for regular DX. It's all dependent upon how I set it up whenever I deploy it. Now, if I set it up horizontal, 3 or 4 foot, 10 foot up off the ground, but set it up in horizontal, it can be an NVIS antenna. But if I set it up as a tall inverted V, it becomes a DX antenna. So it's all based upon how you deploy and set up the antenna and what configuration do you set it up. Are you using it as a sloper, an inverted V? Are you setting it up closer to the ground, high up in the sky? It's really what determines what the antenna is. The antenna, for me, whenever I say an NVIS antenna, when I'm talking to my friends and I say an NVIS antenna, the majority of my friends know what I'm actually talking about is a center-fed dipole that I have set up just a few feet above the ground. I've already shared with most of my friends what I have been doing as far as NVIS antennas. I just call it an NVIS antenna. As I have shared with them all of my experimentation that I've been doing with antennas for intent of NVIS communications, and the ones that I found that work best for my environment at home are the ones that I deploy 3 to 5 foot above the ground, and they're just a center-fed dipole, and that's about it. So there is no such thing as an NVIS antenna. If you hear somebody say NVIS antenna, what they're actually talking about is an antenna of some sort which they have configured to use for NVIS communications. Now, there are a couple companies that sell antennas and they are labeled as NVIS antennas, but I guess what I would say about that is that they are designed with the intent to be used for NVIS only. For instance, one of those style of antennas is an AS2259. It's a style of antenna that is used for NVIS communications that the military had used for a long time. And there are some companies that have picked up that design and have manufactured that design, and they call it an NVIS antenna. To my knowledge, and there again, I could be wrong here, but from the research I have done, an AS2259 is set up and designed primarily for NVIS communications only. So you can deploy it in other configurations. It's probably not going to work very well. The best configuration for one of those AS2259 antennas is the configuration which it was designed for, which has NVIS properties. So that AS2259 antenna, I would refer to that as an NVIS antenna. It's really just 2 dipoles connected to the same feed point is all it is. But it's people refer to it as an NVIS antenna. It's actually just a dipole antenna, similar to a fan dipole, but it's customized and configured specifically for NVIS properties. Misconception number 2, when using a setup, a radio and antenna configured for NVIS communications, you'll only be able to work signals which fall within the local NVIS radius within the 15 to 400 mile radius. This isn't true. Now, I'll explain this. You may only work NVIS style communications within that radius, but you may hear DX. My personal inverted V, when I lowered it down to 25, from 30 foot to 25 foot, My NVIS properties seem to be boosted just slightly, but I still have DX properties on that antenna. Now, if I was to lower my inverted V down to about 15 to 18 foot, my NVIS properties would increase substantially and my DX would decrease. So it's all about the configuration of the antenna. It doesn't limit you to just NVIS. In some situations, it may be just NVIS, but there are some configurations on some antennas where you may get a little bit of both, and you will find that there's probably conflicting information about this out on the internet, but this is one of those things you just got to experiment with for yourself. On my inverted V at 25 foot, I can hear local NVIS. It's not great, but I can hear it. I can talk it. I'm generally about an S4, S5 maybe. But if I get on one of those dipoles that I have set up specifically for NVIS, I can jump to a full 5.9 signal on those, and I generally don't hear too much DX on those, with the exception of the 80 meter. The 80 meter dipole that I have set up for NVIS hears everything very well. That is the only one out of the, I've tested a 40, a 60, an 80 meter horizontal dipole set up about 3 to 5 foot above the ground. And the 80 meters is the only one that I can really hear DX on. And I hear it really well, actually. But I can't work DX off of it. I can only hear. If I was to transmit to the DX stations, they never hear me because that antenna is set up as a NVIS antenna, and DX stations, although I can hear them, they can't hear me when I transmit. So that's a characteristic to keep in mind. It's a different story for every antenna and every different possibility of setting up different configurations for your antennas. They're going to have different properties and different attributes depending on how you set it up. Just know that there are some times when you may set up an antenna and you may actually get a little bit of both. And for me, what I like to do is set up a couple of antennas specifically for use with NVIS, and I leave them in my yard specifically for NVIS, and then I use my big inverted V to do DX. So that's kind of what I do. All right, misconception number 3. For NVIS properties to work on an antenna, it must be installed very high to get NVIS properties. Most recommendations state that the antenna should be installed at least 1/10 or 1/20th wavelength above the ground for the best result. However, in most cases, an antenna installed lower to the ground has proven to provide a lower noise floor and still have great NVIS properties. Most people actually choose to go with the antenna that's closer to the ground because the lower noise floor gives you a better opportunity of hearing those weaker signals. That's what I do. I use the one I live in an HOA neighborhood, and putting up an antenna super high is an issue for me, but putting a 3, 4, 5 foot tall antenna behind my privacy fence works just fine. Or within my yard, I generally don't have any issues with that. So that's what I do. So just know that even though most recommendations say you got to have them really high, I've seen some recommendations for some of the antennas as high as 18 to 35 feet. The highest mine have ever been off the ground has been 5 foot, and I get great signals off of them on low power. So while those are recommendations, sometimes you have to work with what you have. I have to stay within the height of my fence line, and 5 foot's about it for me, and it works fine. So just know that. We'll move on to the next slide. All right, recommendations. Center-fed antennas work best for all this, okay? I'll say that first. Center-fed antennas seem to work best. I do have an off-center fed. I have it set up as an inverted V, and like I said, I do a little bit of NVIS and a little bit of DX on it. That antenna would probably be a better DX antenna than an NVIS communications antenna. It can do it a little bit, but it's not great at it. I actually get best results using a center-fed dipole. Now, I also mentioned that in-fed antennas seem to have more issues when you get up around 80 and 160 meters for NVIS. I've actually tested this. I have not had a lot of luck with in-fed antennas for NVIS properties. My personal experience is center-fed seem to work best. For NVIS properties to work, you want to use a horizontally polarized antenna, parallel with the surface of the Earth. So the most common type of antennas used, and you've already heard me reference both of them already in this presentation, the most common antennas used for NVIS is going to either be a dipole or an inverted V. Let me be more specific. A horizontal dipole or an inverted V. And they both can be the actual same type of antenna. You can set up dipole as an inverted V, but we're talking about a horizontal dipole. Well, let's talk about dipoles first. So an antenna height, this highly debated topic on the internet. You'll find all kinds of numbers out there as far as height is concerned. Some people say a quarter wavelength high. Some say 1/10, 1/20th of a wavelength high for your antenna. My personal experience is that, hey, look, where I live, I can't put an antenna that high. I don't even have trees in my backyard. So I use some fence posts, some plastic fence posts, and push them into the ground. And I use horizontal dipoles 3 to 5 foot up off the ground, and they seem to work just fine. That's what I do. I use 3 to 5 foot up off the ground. I have no problems, very low noise. When using lower height antennas for NVIS, I always recommend using a reflector directly underneath the antenna, about 6 inches above the ground. And in my video, I'll talk more about that when I show you the video of me building the 80-meter antenna I built earlier today. In most cases, a single band tuned center-fed dipole antenna works best for NVIS. So right now in my backyard, I have a center-fed dipole 40 meter. I have another center-fed dipole 60 meter, and then I have an 80 meter. Now, each one is tuned resonant for about the middle of each one of those bands. I have found with my radios, if I tune those antennas for the middle of the band, I can pretty much work the whole band without a tuner, as long as I put the resonant point right in the middle of the band. All right, and so that's been my experience with my radios. All right, so that's for the dipoles. Let's talk about the inverted Vs. Center-fed inverted Vs, generally between, with the feed point up, generally between 15 to 18 feet high, and the end points to the ground is how you would want to set up an inverted V for use with NVIS. You'd want the feed point up about 15 to 18 foot up, and the end points anywhere from a foot all the way down to the ground. Some people don't like putting the end of the antenna on the ground. Some people run it about a foot or two above the ground. Either way, you just want the ends to go toward the ground. That's going to create that angle of radiation that you need for the NVIS properties. All right, so when you lower the inverted V down to the 15, 18 foot range, you'll notice that the noise on your NVIS antenna will actually go down. What we have found is anytime you bring an antenna lower to the ground, your noise is going to go down too. So we found that actually to be true when we were experimenting with our NVIS at home. All right, this setup has great NVIS properties as well as can also work DX, but that really, as I mentioned previously, that really depends on the height of the feed point. Whenever I lowered from 30 to about 25 foot, I got a little bit of NVIS properties. I lowered to 20 foot, my NVIS properties got better, my DX properties got worse. I have lowered my NVIS all the way down to 15 foot, spread my ends of my lines further out. I have gotten great NVIS results on it and almost no DX. So it really depends on how you're setting up the antenna as to which properties it's going to have. You can use a multi-band antenna for the inverted V if you desire. I'm personally using a 10 meter through 80 meter off-center fed, and it's up about 25 foot right now. Like I said, I do have a little bit of NVIS properties on it, but comes time for me to work NVIS communications, I use those horizontal dipoles that I have on the ground, 3 to 5 foot up above the ground. Here's some information about how to make a cheap, quick NVIS antenna. As I mentioned, I have a 40, a 60, and an 80 meter antenna in my backyard right now. So let's see, the 40 meters, I tuned my 40 meter antenna for about 7.200, and I can use it across the whole 40 meter band. Now, I'm just a general class licensed ham radio operator. I can work the whole general band portion with tuning it up in 7.200. The antenna wire length, 65 foot total. I cut the 65 foot in half, wired up to a BNC to banana clip in the middle to make the dipole there. The antenna height, 3 to 5 foot. The 40 meters, I've rented at 3 foot before and got great result. When you start moving it up higher, the 40 gets a little noisy. I found 3 foot's ideal for the 40 meter antenna, and it still works great NVIS, great signal reports, and even do QRP with it. The reflector, I do recommend running a reflector. The reflector is always at least a minimum of 5% longer than the actual antenna itself. So the reflector, I generally just run directly below the antenna wire, about 6 inches above the ground, and that's going to kind of focus it. It kind of makes it into a vertical beam. It works really good when you add that reflector. Makes a big difference. To me, I guess the best way for me to explain it, kind of focuses up NVIS properties on that antenna. All right, so that's the stats for the 40 meter. The only difference for the 60 meter is the length of the wire. So instead of cutting it at 65 foot long for the radiator and 68 foot long for the reflector, you'll cut a 60 meter antenna at a little over 87 feet long and the reflector at 91 feet long. And then the 80 meter, I tuned the 80 meter for 3.9. Now, let me go back one more time. Let me talk about this. The 60 meter, of course, you know, is 5 channels. I tuned it for channel 3, which is kind of the middle, and it'll work on all 5 channels. 80 meter, I tune up for 3.900, and that seems to give me what I need for 80 meters there. 120 foot long for the radiator, 126 foot long for the reflector. And I'll just tell you what I do here. What I generally do when I'm making one of these, I use speaker wire, and it's generally like zip wire. There's 2 conductors there. What I'll do is I'll cut it to the length of the reflector, separate the 2 conductors. I use one for the reflector, and it's already cut to length. And then I cut the difference off of the other wire. So like when I make my 80 meters in the video, I cut 126 foot long, and then I cut 6 foot off of the other piece to get the 120 foot. And that gives me my 2 pieces of wire that I need to make this antenna and the reflector. Supplies. Not much is required to make one of these antennas. Tools, a wire cutter, a very long tape measure, because if you're doing an 80 meter, that's 126 foot long for the reflector. So you need a good long tape measure. And you need an antenna analyzer. You need to be able to check your SWR on the antenna and tune it up for your resonant frequency. And then as far as materials are concerned, you need a BNC to banana connector. You need some wire. It doesn't take very expensive wire. For what I do, I put these antennas up for periods of a time. I'll put them up for like a week, and then I take them down. And then I'll get in the mood to do NVIS. I'll put them back up, and I'll take them down. It only takes me 10 or 15 minutes to put them up once I've already got them cut to length. And so I use 16 gauge wire. If you're going to leave these outside permanently, I would recommend using that steel antenna wire. It probably would last longer. But I've just been using 16 gauge speaker wire, copper speaker wire, and it does pretty good. I have one outside that's been out there for about 3 months. Of course, the elements will start getting to it, but that's why I recommend using that steel antenna wire. It actually will last longer. Now, you can use PVC pipe or plastic fence stakes. 2 of my antennas are set up with pipes. I just cut some pipes to 40 inches long, push them about 6 inches to the ground. That gives me about a 3 foot height above the surface. And yeah, that's kind of what I'm doing there. If you want to spend a little bit of money, you can get on Amazon, and I'll put a link to it down in the below in the description. They have these plastic fence stakes with the sharp metal spikes on the end of it, and you just push them down to the ground. They actually work really great. That's a lot better, a little bit more sturdier than using PVC pipe. And then you need some string or parachute cord. You'll use this as an insulator as you tune the antenna. What I generally do is I put my outer stakes the full length of the reflector. So when it's time to connect the antenna at the top, the antenna is going to be a little bit shorter. So you use a string or parachute cord to connect from the top of the fence post over to your antenna wire, your radiator. All right, so what I'm going to do now is I'm going to show you a video. There's no audio on the video, but I figured I'd talk through it as it's going, kind of show you what we did here. I think the video is probably about 8 or 9 minutes long, but got it sped up to where you just kind of get an idea of what all's involved to set one of these up. There's not a lot to it. All right, so what I'm doing here is just getting all my supplies together. This is one of those BNC to banana connectors, and then the other part to the left there that's rolling, that is a BNC to PL259 adapter, or SO259 adapter, I believe. Long tape measure, there's those plastic fence, yeah, there's the BNC to PL or SO259. Yeah, and you can get all this stuff off of Amazon. I'll put links to all this in my description below. There's a speaker wire. Those fence stakes, I got them off of Amazon too. I can't remember how many came in a pack, but they were real affordable. I think there was a pack for like 20. All right, here we go. We're measuring out the antenna wire, and I got some help in the yard there today, and we're kind of having some fun. We did this during probably the hottest part of the day. It didn't take long. We were trying to work as fast as we could because it sure was hot, this Texas heat. So we're measuring out 126 foot because our reflector for an 80 meter, reflector for the 80 meter is going to be 126 foot long. So I measured out 126 foot long, and there's 2 conductors on that wire. So the next thing we're going to do is we're going to get the end of that wire and we're going to split the 2 conductors away from each other. We'll have 2 pieces of 126 foot long cable. There we go. That's what we just did. We split the 2 conductors away. Now what I'm going to do is I'm going to find both ends of one of those conductors, and I'm going to cut that wire in half. That gives me each side of my dipole. Now, I cut that in half. That was 126 foot long, and I cut it in half. I still need to trim 3 foot off of each side to give me the 120 foot long because the radiator itself only needs to be 120 foot long. But you'll see me do that further in the video. I don't do that until a little bit later. But what I'm doing here is I'm taking the end of the reflector. I kind of just tie a knot on it, and I hook it on the bottom rung of that fence post and just shove it in the ground. And what I realized later is I put that in a bad spot. I had a bunch of little plants and stuff along the fence line, and it's probably a better idea to get it away from the fence a little bit since it's a metal fence. So I didn't realize I put the other one in a bad spot until I got all the way to the other end, but I went ahead and put the second stake all the way at the other far end. All right, and then I go back. Oh yeah, I'm going to move the first stake again because it's not in a good spot. So I give it a new location. Now what I'm going to do is I'm going to go get my 2 wires from my dipole, and I'm going to bring it over to the workbench over here, and we're going to connect it up to our BNC connector. Stripping it back there, and it doesn't matter which wire goes to which side of that BNC connector. It really don't matter. What I do is, because that wire is kind of thick, I split the copper. There's a hole in the middle of that connector to use as kind of like a strain relief. So I'll pass each wire through the hole, and then I crisscross the wires on the back. It doesn't matter which wire connects to which terminal. Both wires should be about both the same length, and that's what you want to do. You want to keep both wires about the same length. So if you have to trim the wires a little bit on either side, you got to trim both. If you're going to trim it to get it tuned, you got to trim both sides a little bit. So, and from what I've learned, a little bit goes a long way when you're trying to get the antenna tuned. So don't trim off too much at a time. Just a little bit will do. Tune it, cut a couple inches off each side, and then go check the antenna analyzer and see if it's tuned up, and do a little bit at a time. So I got the wire connected to the BNC connector there. So the next step I'm going to do is I'm going to take the end of one side of that antenna. I got to go around my flagpole, which is my inverted V antenna holder there. So I go and grab one end of the antenna here, and I'm going to put it on the top rung of that fence post. I just make a loop on the end of the antenna since I know I'm going to be cutting it anyway. Just make a loop on it. And what I'm going to do is I'm going to stretch that wire out all the way to the center connector, and I grabbed me another stake. I'm going to bring it all the way to that BNC connector. I'm going to stretch it out all the way to the BNC connector. Then I put where those two wires crisscross in the back of that BNC connector, I just put that on that hook to kind of hold it up. Push that into the ground. And then I'm going to stretch the rest of the antenna out to the other far side and get it connected. All right, got that done. Now I'm back. All right, so now what we're going to do is we're going to go ahead and put some additional supporting fence posts between our first post and our middle post so that the line don't sag too much, and it'll get our reflector up off the ground. So the reflector is on the bottom and the antenna's on top. And I'm trying to get my reflector up off the ground, because if the reflector touches the ground and the ground's wet, that's going to mess with stuff. So try to keep that reflector up off the ground if you can. And you want to put that antenna radiator on the top rung. Those posts there, those are 4-foot posts. So, and like I said, you can get those on Amazon. I'll put the link to those in the description below. Now what I'm going to do is I'm going to go and cut the 3 foot off of each side to make the antenna itself 120 foot, because I never trimmed that second conductor. So I trimmed 3 foot off of this side, and now what I'm doing is I got a little plastic wire insulator through some parachute cord there. So I'm kind of measured out, then I kind of make me a loop on the end, and I just connect that to that hook there. All right, so that's a 3 foot piece of parachute cord there, making up that gap difference, because the reflector on the bottom needs to extend out past the radiator. So that's what I did. I cut 3 foot off that side. I got another piece of parachute cord with one of them 3-hole insulators. Just ran the wire in through it. All right, and measured it out, put a loop in it. Gonna put it right on the top rung. All right, now we're done. That antenna is tuned for 3.900. Now, I always will put the antenna analyzer on it and just make sure it tunes up right. Depending on the ground, the saturation of the ground, depending on how high that radiator is off the ground, you may have to adjust the length of that antenna just a little bit. And here's me going and making an adjustment on the end. Yeah, I'm not exactly sure how much that was we cut off, but we cut a little bit off. Here's a couple of great references. These are a couple of good videos. I'll put the link to these videos in the description below. These are some other YouTube videos that I had found on NVIS related communications that are very, very helpful. The guy that did these videos was very thorough. VoaCap is a great website. He does a video on how to use that website there. I would recommend getting familiar with how to use it because it kind of explains to you which frequencies to use during what part of the days, etc. Really, really good stuff there. And then let's see here. All right, here's my final thoughts. So first of all, before I go into this, I hope that if you have any interest in NVIS communications, that you'll take some time and do some discovery and some experimenting on your own. While the information I provided, there may be conflicting information on the internet about some of the information I provide. Most of the information that I put in this presentation was put in here based upon my personal experience. I've spent months and months of doing some experiments with NVIS communications using the inverted V, using horizontal dipoles, putting them in all kinds of shapes and configurations. Matter of fact, something I did not mention is that my 60 meter antenna is actually, I didn't want to put it across the full length of my backyard. So I have one leg of my antenna going down one side of my yard, and then I made an L shape with it. The other leg of it's going down the other side. So it does not have to be in a straight line. You can bend and curve the antenna. It generally, I think it probably works better when it's in a straight line or very clean lines. But I got one leg going down one side of my fence, and then where the other side of the fence meets the other leg's going down the other direction. So if you're looking at it from above, looking down, it looks like an L. It works fine like that. So you can put these in a variety of configurations and just test them and find out what works for you. So that's where all the fun is actually building these antennas. It doesn't cost a lot of money to build these. Playing around with the setup and the configuration and the different layouts of the antennas, doing some real world testing on them to find out what's working, what's not working. And most of all, talk to your buddies that also do ham radio. Get them interested in NVIS and bring them along for the journey, because that's exactly what I did. I started telling the folks in my club, hey, look, I got some interest in this, but for me to test this, I need some other folks to get interested too, so that we can do NVIS to NVIS station testing. And before I knew it, there was probably about 6 or 8 of us all interested in doing it. And we've had a blast doing it over the past several months. So talk to your buddies, get everybody interested, get together and make some antennas for NVIS communications one day. I have a hard time getting away from calling it NVIS antennas because they're not NVIS style antennas. They're just dipole antennas. It's how you configure them and set them up that make them operable for NVIS properties. So final thoughts here, please feel free to contact me. My email address is on the screen. I'll do my best to answer any questions you have as time allows me to do so. Thanks for watching my videos. If you like the video, please give me a thumbs up. Please like and subscribe. I'm going to try to continue doing more of these informational videos as time allows. I hope that if you find it very helpful, you share the video with your friends. Hopefully in the future videos, I'll try to start covering these battery builds that I've been working on. I also have some stuff that I've been designing, some proof of concepts and whatnot. I'll try to do more of that as well. Click that bell to receive notifications when I release new content. Thanks again for coming to my YouTube channel. Thanks again for watching this video. Please like and subscribe and share the link to the video. Have a great day, and we'll catch you next time. 73.